Good evening. Welcome to Late Night Tea with Dr. G. Tonight, I made some Good Earth tea, and it says, "He not busy being born is busy dying," Bob Dylan. And it's got mango and cinnamon and um, clover, I think. Anyway, it's delicious. So take a load off, get comfortable, grab yourself a cup of tea, and let's talk about low level and high level prognostic charts. So we're going to need our advisory circular so that you can reference this information. It should be review, but it's one of those things, if you haven't looked at them in a while, you're definitely going to want to spend some time in it. So we'll go over the basics, and then on your own time, you should just go to aviationweather.gov, click on forecast, and then click on the prog charts, and then practice your surface, low, and high level charts. The mid-level is no longer available in the US. So you go to your advisory circular, go to the table of contents, and since prognostic charts are forecast, go to forecast, that section. And looks like in this version, it's chapter 5-120. Hope everybody's doing well. Life is treating you good. Yep, there it is. Cool. All right. Let's rock and roll. All right, low level prognostic chart. This is, to me, one of the easiest charts because everything you need to know is actually on the chart itself at the legend, at the bottom. So let's see, we've got two panels, and I ask you, is it a forecast or observation? And so if we look here, we'll see this says low level SFC to 400 mm, which is surface to 400 millibars. It says the same thing on this panel. This one says 12-hour, and that stands for significant weather prognostic. And this is a 24-hour. So the fact that we have a 12-hour and a 24-hour means it has to be a what? Good, it's a forecast. So these are forecasts. The altitudes are surface to 400 millibars, which is surface up to flight level 240, which is 24,000 feet. And there are two panels because there are two different times, right? This is valid at 1200 Zulu, and then this one's valid at 000 Zulu. 12-hour forecast is the left panel, 24-hour forecast is your right panel. Looking at some of the information here, we've got this red outlined area, and it says that this would mean your ceiling's less than 1,000 feet and or your visibility is less than 3 miles. And it doesn't necessarily always close off. Do you see how sometimes it can kind of be open? So guys, what would these flight rules be? Make a note that the red area of a ceiling less than 1,000 and or less than 3 would be IFR. What's IFR stand for? Instrument Flight Rules. Then we have the blue scalloped areas, which have, again, don't have to be closed off. Like you can see here in Florida that it's not a complete like enclosed area, but it says the ceilings forecast to be between 1,000 to 3,000 feet inclusive, which means inside that area, and or visibility 3 to 5 miles inclusive. Those areas, guys, the flight rules would be marginal VFR, marginal visual flight rules. Then we have the area here that's orange dashed. Now, a lot of times I'll give a test or ask a quiz and the student will say that area has moderate or greater turbulence. That's correct. But if you look, it will give you more specifics. So looking here at the 24-hour forecast, we have this area right here in Southern California. There's two areas. There's one right here, and then there's that one larger one. If you just follow the arrow up, you can see there's two different symbols. The one here that's just one witch hat is what I call it, is moderate turbulence. And then do you see, it's kind of hard to see this one. Here's one over here too. When there's two witch hats, that is severe turbulence. So that area is forecast to have moderate to severe turbulence. Now listen, because this chart starts at the surface, if there is nothing on the, sorry, I lost my mouse, on the right side here, that means that it begins from the surface and goes up to 7,000 feet. You add 2 zeros. So we will not, it is not, we're okay flying through moderate turbulence, guys, but when we see that severe, that's kind of a red flag. I know it's just a forecast, but we would definitely want to keep an eye on it. We do not want to ever knowingly fly through an area of severe turbulence. Not any of our aircraft are certified for that, whether it's CRJ, ERJ, Boeing, Airbus, none of them. So this one is a bit of a concern on that forecast. And then you look here, and this one's got moderate turbulence, and it's from the surface up to 7,000 feet. We also have this light blue, like this cyan color. There's two of them. It can be dashed or it can be zigzag. If it's dashed, it says the freezing level is above mean sea level. But again, that answer is not sufficient during any test or check rides or FAA exam because they give you more information on the chart. So for example, when you look here, this line that's swooping through Texas, kind of follow it all the way through the US here. And you can see twice, 2 or 3 times it says 040. So all along that line, guys, your freezing level is at 4,000 feet, which just means at 4,000 feet, the temperature will be 0 degrees. That does not indicate icing necessarily, because what does it take for ice to form? There's 2 ingredients. Temperatures at or below freezing and visible moisture. This chart does not show us visible moisture in that example. It just said, hey, this is altitude where it's going to be 0 degrees Celsius. But we would keep an eye out on that. We can look at other charts to see where clouds are at or the precip. But all along here is 4,000 feet. And then you can see the zigzag line here. This means that the freezing level is at the surface. And that's really it to these charts. Every now and then they'll give you a thunderstorm, another kind of area, which I don't see on this one, that says thunderstorms imply possible severe or greater turbulence, severe icing, and low-level wind shear. There's not any on this chart. So here's just another image for us to look at. Let's look over here. Let's look at this. So on the 12-hour forecast, let's look in Tennessee, we've got a number of things going on here. We've got the orange dashed area, which sometimes you have to do a little digging, but you can see that there's moderate turbulence, and it's from the surface up to 13,000 feet, right? Add 2 zeros. I want to find one. Oh, here's one. Look right here. This area has 2 numbers. So this means there's moderate turbulence. The bases are at 180 and the tops are at 240. So it's from 18,000 feet up to 24,000 feet. Moderate turbulence may not be a reason to fly around that area, but it is important that we know of it ahead of time. As dispatchers on the ground, we definitely want to keep our pilots informed. The number 1 cause of flight attendant injury is turbulence. And also passengers don't like turbulence. We want to get the smoothest ride possible. So if we can't, if you get up there and you're having a bumpy ride and you are flying for an air carrier, you might ask your dispatcher, can you find me a smoother ride or a better altitude? And they'll know what you mean. Tell them that it's bumpy. Because, it makes passengers uncomfortable, and sometimes it can cause passengers to get sick. So we do want to try to avoid those areas if possible. What else? So we've got this red area. What does that mean? IFR, right? Looking here in Tennessee again, that light blue line. Freezing levels at 4,000 feet. The zigzag means freezing levels at the surface. Here's another area looking at the 24-hour forecast, pointing to this area right here where we have moderate to severe turbulence from altitude 14,000 feet up to flight level 240. Again, these are your low-level prognostic charts. Sometimes they're called low-level significant weather charts. they give you the forecast for the 12 hours and 24 hours. So it kind of starts to paint a picture. We have several products that we want to look at right before we fly, take off and fly, and also that we want to monitor throughout our flights. This is one of them. So that was pretty straightforward. Now let's go to the high level prognostic chart, which is obviously going to be higher altitudes. So we've got the surface level one that just gives you the forecast at the surface. We didn't talk about that one in this video lecture. Then we have the low level that starts from the surface and goes up to flight level 240. And then your high level prognostic chart is also a forecast. And these altitudes are on the chart, but they start at flight level 250. So there is a 1,000-foot gap there between the low and high. But it starts at flight level 250 and goes up to flight level 630. So you add 2 zeros to the altitudes as always. So that's 25,000 feet up to 63,000 feet. Sorry, I got thirsty. Okay, so the best way to do this is the same way as we did the other one. I just kind of point and talk about them, make sure that you have your advisory circular, and that if you have any questions, that it's all in your book. Really, you just have to take the time to look into it. So I would skip the mid-level because, again, they stopped providing those for the United States. I don't know why, they just did. And so the information begins in chapter 5 on page 5-130 in this version. This is the AC 00-45H, change 1. Okay, so let's look. Up here, in case you ever forget, the altitudes, it's right up here, 250 to 630. This is a great product, guys, to look at because everything that's forecast to happen at these high altitudes, obviously you're going to come down into the lower atmosphere, right? So it's definitely going to affect us for our flights, looking at this. So let's first start with these numbers in these boxes. The 300, 340, all throughout the chart. These are our tropopause heights. Okay, what is our tropopause? Do you guys remember? Anytime it ends in pause, it's the boundary layer. So we've got our troposphere, which is where we fly at, and it's it's the surface. The altitudes vary, actually, right? But let's say anywhere from the surface up to, I don't know because it varies, but 30,000 feet or something, right? But we have our troposphere, which is where we live, breathe, fly. And then we have the tropopause, which we can also fly in because we can see these numbers are lower. And then we have the stratosphere. So the tropopause is the boundary layer between the troposphere and the stratosphere. And it varies throughout the region. There's also different high-level prog charts throughout the whole world. So I obviously clicked on the one for our region in the US. But guys, I do want you to know the significance of knowing where your tropopause is. And the significance is that is generally where our jet streams are located, as well as clear air turbulence. And so the jet streams are the areas in green that I'll decode in a minute with you. And then generally speaking, these areas that are yellow are clear air turbulence specifically, because this is a high level chart and clear air turbulence is a high level type of turbulence. So the height of the tropopause, what's the significance? Generally, it's where we find our jet stream and our clear air turbulence. Then you can see you have these different ones throughout the chart that have an L and it has an arrow pointing down. There's also ones with an H pointing up. These are the lowest point of the tropopause in that region, and these are the highest point of the tropopause in that region. So it's 27,000 feet. Here's your lowest point of the tropopause, 32,000 feet. Up here is your highest. You can see there throughout the chart. Here's a high point of the tropopause here at 58,000 feet. Now let's look at our jet streams. So jet streams, fast, narrow band of air moving west to east. Jet streams are great if you are flying west to east because it would give us a tailwind, right guys? Which would get us to our destination faster and we would burn less fuel and have less drag, right? Increase in with our tailwind. But if we're going to the west, then a jet stream, we would not want to be at that altitude because that would be a substantial headwind, we're talking about anywhere from 80 to over 150 knot wind. So that would be a very substantial headwind, which would increase our fuel consumption, meaning we would burn more gas, and it would be less efficient, right? So we do not want to be on the jet stream if we're flying to the west. So we look here in our jet stream. Now, first of all, in order to be a jet stream on this chart, it starts at 80 knots, 80. If you're following along with me, I'm on page 5-131, section 5.19.3.1.4. I know. It says a jet stream axis with the wind speed of more than 80 knots, is identified by a bold green line. An arrowhead is used to indicate the wind direction. The wind change bars, which are double hatched light green lines, positioned along a jet stream axis, identifies 20 knot wind speed changes. Let me translate that in English. So we start here, and we're at more than 80 knots. Now, here's a wind flag. Do you guys remember how to read these? And they're consistent throughout various charts. The thick flag indicates how many knots? Good, 50 knots. And then the solid lines here are 10 knots. And if it was a little half mark, it would be 5 knots. So this one is 50, 60, 70, 80, 90 knots right here. Now we go over here, and there's those double hatch marks. They were talking about the 2 lines. Those indicate 20 knot wind speed changes. Now, the only way I know that that's an increase and not a decrease is because there's another wind flag here that is higher. So if you see a wind flag to the right of that, then you know these are indicating 20 knot increases. So here's what I mean. We started at 90 knots, and then it went up 20 knots here. So that's 110 knots. And then right here, it went up another 20 knots. So now we're at 130 knots. We get here, and the maximum speed is 3 big flags, which is 150 knots. After this, guys, there's not any more wind flags, just those hatch marks. So this means it decreases 20 knots. And that's just the symbol, right? Those 2 lines mean 20 knots. Each line is not 20. Does that make sense? So it goes from 150 knots and it decreases 20 knots. So now it's at 130. And then right here, there's 2 more. So then it decreases to 110 knots in that location. We'll practice another one in a minute. Now, the jet stream is at, right here, it's at flight level 380. And right here, it's at flight level 370. Well, what are those numbers below that? Those numbers below that, it's in your book. It says the jet stream vertical depth forecasts are included when the maximum speed is 120 knots or more. Jet depth is defined, that was a hard one, as the vertical depths of the 80 knot wind field above and below the jet stream. So basically what they're saying here, guys, the easiest way I remember it, is your jet stream's at flight level 370, but you can experience these fast winds anywhere from flight level 210 up to flight level 530. Okay, let's read another one that's easier. Let's read this jet stream. This guy right here, jet stream's at flight level 250, and the max speed is 100 knots. There were no changes along that one. All right, let's do this one. So we know it starts here at more than 80. Goes up 20 knots, so what's it going to be right there? 100, 120. Here's your maximum, 130 knots. Because it's to the right of the wind flag and there's not any more, I know that that is a decrease of 20 knots. The jet stream is at flight level 390, and you can experience those 80 knot or higher winds from flight level 300 up to flight level 490. Okay. Over here, guys, we have an active volcano, and this would be the name of the volcano, and this is the latitude and longitude coordinates. And here are 1, 2 more here. You can see there's the names there. They're kind of offset. We have a lot here. And I don't speak Spanish, so I'm not really good at those. I'm not even going to try to say some of those. But there's the name, and then the latitude, longitude coordinates. And the volcanic eruptions, guys, are important to us. There's another advisory called a volcanic ash advisory. And those would be really important to monitor, especially with international operations, because a volcanic ash cloud appears the same as a cloud on the satellite imagery, so you can't tell. And encountering volcanic ash would definitely be a reason to consult your quick reference handbook. And it would say to exit immediately, do a 180-degree turn. Entering volcanic ash is definitely an emergency. Seizes up our engines, as well as I'm trying to think what the QRH says specifically for the Boeing 737 that I have, but basically our engines would quit. We would have smoke in the cockpit. There would be a peculiar odor. You'd have to put your mask on, and it really is catastrophic. So they have a whole list of how you would handle it, but the first thing always says do a 180-degree turn and just get out of it. So that's why we want to know where the volcanic eruptions are at. Let's see, now let's look at, there's, I think, two more things I haven't gone over on the chart, and that's the red areas, scalloped areas, and the yellow. So let's look at the red scalloped areas. A lot of times my students will not know what that is. And for some reason, this chart gives my students a hard time. And my advice is, if you ever feel yourself getting stuck on a check ride or a test and you feel a little overwhelmed, just take a step back and look at the chart. Most of the time, it will tell you there are arrows pointing to it. It's just sometimes hard to find. So like this one here, if you look, there's an arrow way up there. See that? So this is an isolated embedded cumulonimbus. The tops are at flight level 380. The bottoms, guys, have the 3 X's. Now listen, where did I say this chart begins? Look back, look on the top right in that blue box, and where does this chart begin? Where's the chart's jurisdiction? Flight level 250. So when this goes below the chart, it does not know where the base is at, so it puts 3 X's. So the way we would read this is in the forecast, there's isolated embedded cumulonimbus, which is a thunderstorm, where the tops are at flight level 380 and the bases are below the chart, which means somewhere below flight level 250. You look at this one right here, isolated embedded cumulonimbus, the tops are at flight level 420, the base is below the chart. How does this affect us? Let's look at this one, this little guy right here. Isolated embedded cumulonimbus, tops are at flight level 320, bottoms are below the chart. Well, guys, the rule of thumb, it's definitely, we never fly through a thunderstorm, and we never want to go below a thunderstorm. So our options are to fly above or to circumnavigate, which means go around. Now, even though I don't see it on this chart, the rule of thumb is for every 10 knots that the thunderstorm is moving, be at least 1,000 feet above the top. So, for example, down here, these guys, occasional cumulonimbus, tops at flight level 530, we are not flying above those. Those are massive thunderstorms. Most of our aircraft are not capable of flying at that altitude. We'd have to know our service ceilings, right? Most of our Boeings and Airbus, we're talking about flight level like 410 usually, right? We usually flying around 37,000 to 41,000 feet. So it doesn't tell you how fast these go, but you would have to look at a convective SIGMET forecast for that. So, sometimes we can fly above them, sometimes we can't. The other option, of course, is to fly around them, which is at least 20 nautical miles. Sometimes that's not sufficient because we do have to remember these are just a forecast. You could get up in the altitude, up in the plane, and flying at altitude, and the thunderstorm could be bigger and faster and stronger than what was forecast, and ends up you're flying too close, right? So it's always better to be on the safer side and to also have more fuel whenever you think there's thunderstorms along your route. And I always recommend an alternate, even if it's not legally required. The last thing I ever want you guys doing is flying and you're in an uncomfortable situation where you're really wishing you had an alternate airport that had already been planned, that you already knew you had the fuel for, the weight and balance, you already calculated your VREF speed and all that stuff. You know what I mean? It's just always better to have that plan in place ahead of time. I don't care if you have to bump a few passengers off. Our priority as dispatchers and pilots, it's always going to be safety, 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 safety. If we have to bump a few passengers so that we have a solid plan, then we should always do that. Always, always. And then the last part, guys, is going to be these yellow areas. And I want you guys to notice that they are generally always along the jet stream. And that's because the jet stream is creating that instability, those really fast winds, and it is generating turbulence. So that's clear air turbulence. So we look here at this one, this little one, boop, we've got the arrow. We've got one witch hat. And what did I say that means? Moderate, right? So this one is moderate turbulence. The tops are at 33,000 feet, flight level 330. And the base of this clear air turbulence is below the chart, below 250. We have another one right here where we have moderate turbulence from flight level 410 to below the chart. And then the same over here, moderate turbulence 410 to below the chart. Now, a lot of times, I'm going to ask you this also, I want you to know this. A lot of times there are thunderstorms that form along the jet stream. I want you to think for a minute why that might happen. I want you to think about what ingredients are necessary to form a thunderstorm. Is your phone put down? Are you paying attention? Okay, good. Okay, what's necessary for a thunderstorm? Instability, some type of lifting, and moisture, sufficient moisture. So we've got that warm air that's pushed rapidly up in the atmosphere, right? Starts to form the cumulus cloud. We continue to have that extensive vertical development where we go from the cumulus stage into the mature stage, and then we get into the dissipating stage. Now, this jet stream, guys, it creates instability because as it goes really fast, this one right here, 150 knots through the atmosphere, it definitely creates instability. And it also can be that lifting force, right? Needed to push that warm, moist air up. So all we need now is moisture, and then we have a thunderstorm, which is why oftentimes you'll see the red scalloped areas along the jet stream, as well as the clear turbulences along there. These are some other symbols, maybe not as common, that I wanted you guys to see. Tropical cyclones in the northern hemisphere. You can see the arrows pointing a little different because of the Coriolis force does affect how those rotate. And then I showed you this one already, a volcanic eruption site where they would give the name of the volcano as well as the latitude, longitude coordinates. And then this would be a sandstorm or a dust storm. And again, anytime you see two numbers, that's the base, the top and the base. And then I just want to pull up some from right now and just see if there's anything interesting we can find while we are on this video together. And I want to show you how to look them up. So go to aviationweather.gov, click on forecast, click on prog charts. Scroll to the bottom, and this is where you would see your surface analysis chart if you wanted to look at this, where you can see it's definitely a forecast because you see the drop box, and we've got the different valid times, 0, 100 UTC, Monday, July 13th, 2020, all the way through Sunday. We've got an occluded front, stationary front, low pressure system, high pressure, cold front. These are troughs, right? Elongated areas of low pressure. The light gray lines are our isobars, equal lines of pressure, and millibars. And the pressures are relative to that day. So like, for example, here's a high pressure at 10, 11 millibars, but that pressure might be a low pressure another day. They basically look at all the millibars throughout the United States. The computer system connects all the ones, kind of connect the dots, excuse me. Wherever the lowest pressures are, there's an L, and the highest pressures, there's an H. We know that in a low pressure, our air flows counterclockwise to the left, and in a high pressure, it flows clockwise, right, to the right. So anyway, here's, oh, and I did want to show you here when you click info, I love this, so definitely do this. and I would print this off. This is an excellent explanation of fronts and all the symbols that you might see on a surface prog chart. I would just print that right there and use that to help you study. Okay, so anyway, I'll just show you what it looks like here. Once you do more of the forecast, it'll actually show you the areas of precipitation in green. You can see here that it'll tell you what the colors mean. So let's see. Cool. All right, so go back to forecast prog charts, and here's our low level prog chart. So we've got the 12-hour and the 24-hour forecast. Wow, not much going on at all. We've got at 16,000 feet is our freezing level right here. These areas in red are IFR. This area right here has moderate turbulence from the surface up to flight level 240. Oh, and then the blue scalloped areas out here would be marginal VFR. That one's pretty easy. And then let's look at our high level, and you would just click on this box. All right. So the H530 means the highest point of the tropopause in that region is at 53,000 feet. 390 is the tropopause height right there. Here's the lowest point in that area of the tropopause. Right here, both of these scalloped areas, there's isolated, embedded cumulonimbus clouds, which means thunderstorms, right? Cumulonimbus. The tops are at 40,000 feet, flight level 400, and the bases are below the chart. So more than likely, you'd want to fly around those, right? Because that's pretty high. This one definitely. Isolated embedded cumulonimbus is forecast to be at 48,000, and the bases are below the chart. This jet stream right here is at flight level 410, and the max speed is 100 knots. That seems to be pretty consistent, 100 knots over here for both of these different altitudes. Here's the same volcanic eruption sites I showed you on the other presentation. Here is moderate to severe turbulence, right? That's that yellow area. Tops are at flight level 420. The bottoms are, the base is below the chart. And just for another example, even though it's not in the US, I wanted to show you this hash mark here. So this jet stream, we've got 100 knots here because we know it started at 80, goes up 20 knots, right? So it's 100 knots there. And then the max is 110 knots. And then to the right, because there's not another flag, wind flag, I know that's a decrease of 20 knots. So 90 knots, and it's at flight level 290. Well, anyways, guys, that's a wrap on the low level and high level prognostic charts. I hope that it was beneficial, and I hope you have a wonderful night. I hope you enjoyed your late night tea with Dr. G, and I will see you guys soon.